Hey, today, need everyone's attention up here. Today we're talking about the trig functions and translating them, which I personally believe that this is one of the easier of the trig topic lessons because you have a background information about translating functions. So hopefully you saw that as you went through page 604 there and looked at the different phase shifts. So notice this one right here, the way they write it out, you can translate your periodic function by horizontally and vertically the same ways as other functions. We've talked about h and k this year. So all you're doing is moving it h units to the right. So the minus h, remember minus means you're moving it to the right, and k units up or down. The h is coupled with your x variable. So if you see a number in those parentheses with the x, or even more so thinking of x as theta. Okay, we're going to be thinking of x as theta there. So, which also means your x-axis is your theta axis. But if you see a number coupled in there with theta, then it's your h shift. If you see a number outside of the whole piece, it's just being added on or subtracted on at the end, that's your k shift. Okay, so you have your same hk that we've discussed all year. All right, so we get to come back to that. Okay, any questions when you read through this? Understanding what they're talking about? Yeah, Julia?
Is there not another name for a vertical translation?
You mean rather than a phase shift?
Or like horizontal is phase shift?
Yeah, horizontal translations are referred to as your phase shifts. Vertical, we don't give it a special name that we're going to reference. Okay? Sorry. I know. So yeah, that's a good point. Your horizontal translations, if you didn't catch that, that's your phase shift. So looking at question number one. Question number one, what is the value of h in each translation? Describe each phase shift. Use a phase shift like 3 units to the left. All right. So what do we got? Volunteer? Katie? Yeah, 2 units to the right. Good. Value of h is 2, which is 2 units to the right. Remember, subtraction means you're going to the right. Okay, how about B? Go ahead, Justin. Good. 4. So is it 4? It's actually negative 4, right? So if we think of f of x minus h, okay, in order to get that become a plus right here, h would have to be negative. So f of x minus negative 4, which makes it plus 4.
Yeah, but it's 4 units to the left.
Okay.
It's still 4 units to the left, though. It's not
Yep.
negative 4 units.
4 units to the left. All right. How many got that? Okay. We'll see as we get a little further here. Let's look at this graph. So number 2, the graph of f of x equals cos x, shown at the right. Sketch the translation for A and for B there. Everyone show your neighbors there your translation. Okay, you need to graph
One
it,
goes
man.
up and that one goes this way.
You didn't graph it though, that's lame.
No, I didn't because
Yeah.
I didn't realize that's graphic on the back.
Good hint is when I say, hey, there's graph paper on the back.
It's a good hint.
Yeah. Okay, I've added some notes to my note page here. Maybe you'll add them to yours. But it talks about if we're going to. Ooh, do I have the right page there? That's the wrong one.
Well,
Too complicated.
Yeah, that's the next one.
what's like math?
Let me get the actual one. Here we go. Let's try this. So we'll add some notes to that. So if we are graphing that, the first thing you need to do is actually graph the function f of x equals cos theta. Okay, so it says graph the f of x equals cos theta, and then once we get that graphed, and notice I just used my max, my 0, my min, my max, or excuse me, my max 0, min 0, max. But I went through and I used a scale of, what did I go up by?
1/2.
Yeah, I went up by pi over 4 here.
Oh, well,
Okay?
it's not.
All right. Hold on, I'm going to pause it here. Using a transparency here, but if I've graphed that, okay, can anyone tell me why I maybe used pi over 2? So one person, talk with your neighbors real quick. Why did I use pi over 2? Okay, volunteer, why did I use pi over 2? Still only one person. Got about 6 now. Okay. Brittany, what do you think?
Is it because when you use pi over 2, both your x-intercepts are labeled?
Okay, very true. Both your x-intercepts are labeled. Okay. That's not why I used it, but that's a nice piece there. Yeah. Go ahead, Sid.
Because that's what you're shifting it by.
Yeah, letter B, you're shifting it by pi over 2. So if you're going to shift horizontally and vertically, you want to make sure that you're using a scale on those that makes it easier to shift. So if I'm going to shift pi over 2, at least have pi over 2 or smaller on your graph, okay, or a factor of pi over 2. In this case, I went up by pi over 4, which is a factor of pi over 2. So if I'm moving that graph 2 units up, I'm taking all of these points, these major points here, the ones that we've talked about, and we're just shifting them up 2 units. So it's just sliding that graph up 2 units.
Actually, you'd have to move it up 4 because your scale is of 1/2.
Oh, good call. Yeah, I went up by 1/2. Thank you. All right, so that means I'm actually going up 4 units since I went up by 1/2, which would be about right there. Okay? Yep, since I went up by -1 there. Good call. That's a good catch, Brooks.
Got you.
Okay, how many had that on the graph? Maybe not using the same scale. Okay, well, let's see. Pi over 2 units. I'm shifting it pi over 2 to the, which way?
Right.
Right, so that means each of these is going pi over 2. Now, pi over 2 is what length? How many?
2.
Good. It's 2 units, or two lines. Thank you. Okay, so we've shifted it. Now, notice I have my y-axis shifting here. Generally, your y-axis wouldn't be shifting. So if I'm actually graphing that, thank you. Okay, so if I'm actually shifting that, you're going to have, and you're wanting to go 0 to 2 pi, and I'm going 2 units to the right to make it look like that. Where do I go from here? I need to get back to this line.
Go down.
Yeah, I'm going down, right? I go to the origin. And if I shift pi over 2 units to the right, or, what is pi over 2? How many degrees?
90.
90 degrees, which is, remember cosine and sine, they're a phase shift of 90 degrees. When you shift a cosine graph 90 degrees, you get the sine graph. You get the sine curve. Okay? So cosine is the complement of sine. That's what cosine means. Okay? Very good. 90-degree shift. There we have it. So really, we could just stop it right here now, since that's our 2 pi mark. We don't need this other piece. That piece could be erased. Or you could leave it. Okay, questions? What do you need to label on every graph?
Zeros and asymptotes.
Zeros and asymptotes. Okay. Moving on, next piece. And while I put that up, I want you to talk to your neighbor, make sure they understand what's going on.
You guys get it? You guys I know what's going on. Do you guys know what's going on? I know. Do you? What's going on?
Hey, time's up. Questions? Any questions at all yet? Everyone rate themselves 1 to 5. Do the basic shift. The goal is going to be to do each shift individually, which we just did, and now put them all in at once. So if I'm graphing this, y equals 2 sine x minus pi over 3. Remember, x can also be called
Theta.
theta. Okay, theta minus pi over 3 minus 3/2. So this would become our theta axis then. Okay, so first step, you need to graph your original sine curve, and then you're shifting it pi over 3 units to the right and 1.5 units down. Okay, so each point shifts just like that, and that's what this is showing here. Each point shifting pi over 3 to the right, 1.5 units down. Now notice their scale here, they went up by
5 or 6.
is it pi over 6? Yeah, pi over 6. So 2 lines is a length of pi over 6.
Pi over 3.
Or is pi over 3. Thanks. Got Brooks here checking.
Gotcha.
All right, there's number 4. Hopefully you graphed it. Notice I did not connect my dots this time. I didn't connect my dots because I'm going to be just sliding my graph. Okay, so the first thing to do when I'm looking at this graph here is y equals negative 3 sine of 2x minus pi over 3 minus 3 halves. First thing I need to do is ignore the shifts, the pi over 3 and the 3 halves, and think of it as just negative 3 sine 2x. Okay, you're familiar with graphing that. Negative 3 sine 2x, negative 3 is your A. 2 is, what's 2? That's our B. That's how many cycles there are. So from 0 to 2 pi, we should have 2 cycles. This is what we've been doing. So we start here, we go down to negative 3, we go up to our max, back down. So there's 1 cycle right there, and there's our second cycle. I used a scale of pi over 6. Why did I use a scale of pi over 6? Someone besides Brooks this time, even though that I don't mind Brooks. Or Sid. Sid's already volunteered. Come on, man, if you haven't volunteered. Jacob. Everyone talk with your neighbor. Why would I use pi over 6?
Because it's a multiple of pi over 3. Or it's a
Multiple of pi over 3 and
Okay, time's up. Why use pi over 6? Sophie? Yeah, you have a minus pi over 3, so you're going to do a phase shift to pi over 3. Well, pi over 3 is a factor of pi over 6, right? How many lines is that, Brooks? Yeah, 2. Brooks corrected me earlier. So, all right, so we're here. Got my graph. I got all my major points for it. I'm shifting, so I did my graph, then I'm shifting pi over 3 to the right. So each one's going over 2 lines, pi over 6, and there's pi over 3. Okay? And then I need to shift 3 halves units down. What is 3 halves? 1.5. Now, if you don't mark your scale on the side, then I'm assuming you're going up by single units. So I need to go down 1.5. That would be my new graph. Now, really, it would be helpful if I didn't have this line in here again.
Yeah.
Right? Let me grab my little erasing tool. It's like magic.
Wipe away magic.
Yeah. Oh, I wiped away one of my points though.
That's okay.
That isn't okay.
You have a draw. You have a draw again magic tool.
There we go.
Well.
All right. So I've got that. I graph it. Try to get those curves in there. So there's 2 pi right there. I could stop actually right there. If you want, you can continue it through. Okay, what do I need to do here?
Continue it back to the y-axis.
So what does this represent?
That represents.
So let me go back to where I was. There's my original, right?
Mm-hmm.
This represents a 0 here. Where do I go after that 0?
Down.
If I kept going, do I go down from here? Go up? What do I do?
Up.
I keep going up. I go up to a
Maximum. 3.
Holy moly. All right, we'll wait. We're going to wait for your groups to figure it out, I guess. We've got Brooks that knows it.
Yeah.
Okay, Katie, where am I going up to? I'm going up to a maximum. So when I shift it that far over and that far down, I am going up to a max. I'm going to keep going. So where does that take me to? Sid? What's that? 1.5. So right up there. Yeah, you could look right here, right? It has to. Your maxes will all be at the same level. Okay. All right. And the other thing to remember, if you're drawing your arrows on here, please make sure you actually make that bend down before you draw your arrows. Don't put your arrow right here, showing that it goes off into space. Okay. Okay, how many got it? All right. Very good. The next piece, you had this one here. I'm going to quickly go through these. Okay, if this one, on number 5, I'm shifting the graph. I've graphed it from 0 to 2 pi. First one to go. Okay, I want to shift to the left, pi over 2, which pi over 2 is here. So going that way?
Yep.
Okay, and going up 2.
Yep.
So right there. So on this graph this time, I'd actually have to move it over again, right? I'd have to slide it up to there.
What? Your points? No.
Yep.
So go down.
Thank you.
Yeah. No problem, dude.
Hey, how many people have more than just, how many people are actually following this? How many of you have this graphed on your paper? Ooh, tough back. All right. There we go. So is my arrow good there? No. Need to fix it, right? What's wrong with it?
It's going to not space.
Okay, it can't be going, it's not continue going down, it's going back up from there. So at least turn it and then put the arrow. Okay, how about here? Can I just go up? Yeah, and this one it goes up because we still have to go up to a max, right? Okay, last one. Got right here. Letter B. Y equals 2 cos pi over 2 x plus 1 all minus 3. So first you need to ignore the plus 1 and the minus 3 and graph just y equals 2 cos pi over 2. So in order to find what our period is, you need to do pi over 2, or excuse me, 2 pi over b, or 2 pi over 2, which is 4, meaning one cycle is at 4. All right, so guys, when I go through that, I'm just assuming that we know how to do that now because we just finished chapter 9. All right, okay. So from there, we're shifting 1 unit to the left. And how many units up or down?
-3.
3 down. Is that good?
Nope. One more.
There we go. All right. Good now?
Yes.
Yeah, it looks pretty good. We start here.
So many.
Yeah, a lot of dots, man. Okay. I only need to go to 2 pi, right? 2
Nope.
pi is at,
Yeah.
Right after 6.
yep, so tell me when I'm at 2 pi.
2 by.
Good.
Right about there. So I could stop there. Okay. Could put my arrow there and be done. That erasing tool is amazing.
I know. That's racing too.
All right. Very good.
Looks good.
Okay. That's what you're doing today. All right. I'm assuming not many of you made it to question 6.
Nope.
If you did not make it to 6, you need to answer that right now with your neighbors while I'm handing out your assignment. Okay, so writing our function in that a, b, x minus h. Notice I don't have a b here. So how am I going to get that b term? Go ahead, Noel.
Take out the 2 and 2.
Good, so factor out a 2 here. So that becomes 2 times x minus 2. All right, so we get y equals a, which is 3, sine, b, which is 2, good, x minus 2, all plus 1. So what's our amplitude? Good. Amplitude's 3. That's still our A turn. Okay. Describe any translations. What's our translation here? Go ahead, Jada.
We shift 2 units to the right.
Okay, so phase shift is 2 units to the right.
Yeah, and then 1 shift upwards. 1 unit.
All right, and that 1 unit up's from our K. Okay, really, that's all we did today. All right? Okay, this has all the math-ese behind it. There you go. You can write that on your paper and show it to your friends and go, look at this. They look at you with blank stares. It's awesome. Yes?
What was the period?
Oh, the period? The amplitude. Oh, we didn't do the period. Yeah, the period, remember, is for its sign. 2 pi over b. So in this case, it's just pi. 2 pi over 2.
Hey, have you guys done
Thank you.
56
Good
yet?
job. Woo. All right. You have 4 problems on your. The question was on when you're graphing them. So for instance, when I had these graphs, should I, after I graph the basic function and I shift it, do I keep the old points? No, erase the old points from the basic function. So when I'm graphing y equals 2 cos pi over 2 times quantity x plus 1 minus 3, graph y equals 2 cos pi over 2, just put those points, shift it, but then erase the original points. And just keep your shifted graph. Okay? And make sure you connect the dots on your shifted graph.
Good.
Good question.
Thank you.